Good morning, ladies and gentlemen. Here we are doing our final lesson that we need to learn prior to taking the AP test here in May, and it is actually 7.3D, volumes of a known cross-section, or finding volume from a known cross-section. Well, we did 2A yesterday, and so we are going to do 2B today. And then we are going to do one where our cross section is perpendicular to the y-axis. And then you're going to work on your homework and we're going to start reviewing. But yeah, it's kind of exciting. So we are looking for, our area region. Remember, we first want to graph our area region, and we're looking for the area between these two curves right here. And in that area curve, if I look at x squared minus 4, that's a parabola with a y-intercept here of 0, negative 4. And that's going to be a parabola opening up this way and opening up this way. And we also, so right here, this is y equals x squared minus 4 equals. And then my other one is 4 minus x squared. So that's going to have a y-intercept up here at 0, 4. And that one is going to be opening down because of that negative. And they should intersect. They should have the same exact y-intercept or x-intercepts. And they're going to intersect right there. So this one is y equals 4 minus x squared. So here is my area region. And remember, we're symmetrical here, so we have options on how we're going to do this. So there's our area region, and we are looking for our cross sections, our isosceles right triangles, perpendicular to the x-axis with one leg in the region. So that means I have, here is a leg. And that leg is going to be here. And if it's a right isosceles triangle, it's going to kind of come up like this. I don't like how I drew that, though. It makes it look like it's sitting in the plane more. And I don't want it in the plane, so I'm going to draw it more, a little bit like this. There's my right angle. And there is my area region in which I am talking about. Well, my area region in which I'm talking about is, it is a right triangle. And we know the area of a triangle is 1/2 base times height. Well, we need to look and see what the heck is the area of the base, or what is the length of the base? Well, if this is my base, that is the length of this guy right here. And how am I going to find the length of that red line? Well, the length of that red line is top curve minus bottom curve. So that base there is actually going to be top curve of 4 minus x squared minus the bottom curve of x squared minus 4. And if I actually came through and simplified that guy a little bit, where I take my 4 minus x squared minus x squared minus 4, well, that's really 4 minus x squared minus x squared plus 4. It's really 8 minus 2x squared. That is actually how long that side is right there. Oh, crumb. Okay. So I'm going to clean up my rectangle again. That's kind of... And so I know this base is going to be 8 minus 2x squared. Well, this is a right isosceles triangle, which means this side is 8 minus 2x squared as well. So my area equals 1/2 8 minus 2x squared times 8 minus 2x squared, which my area function in terms of x is really going to be 1/2 8 minus 2x squared squared. And what do I get? Well, that's my area function. And remember, when we are trying to find our integral, okay, what we're doing is we're finding the integral. The volume is going to be the integral from a to b of my area function times a little bit of thickness because I'm perpendicular to the x-axis. Well, what that means is I have a constant here of a half. So my volume is going to equal, I'm going to pull my half out, and I'm going to say my area function is 8 minus 2x squared squared dx, and I also need my limits for x. Well, I have options here, guys. Remember, if I'm going from x to x, I could go from this one. Okay, remember, 4 minus x squared equals x squared minus 4. So we're actually looking when 2x equals 8. So when x squared equals 4, when x equals plus or minus 2, that is this point here. So this is negative 2 comma 0. And this one over here is 2 comma 0. So I can integrate from negative 2 to 2 if I want to do that. Okay, or I can look at symmetry. Okay, or I could say my volume is going to equal, well, if I think of this 1/2 integral, if I went from 0 to 2, well, then I got to double this region times 8 minus 2x squared squared dx. I could do that as well. Both of these integrals are going to give me the exact same area region or the exact same volume. And when we type that into our calculator, we are going to say a calculator, we are going to take, well, if I took 0.5 times menu 45, my integral, if I went from negative 2 to 2 of a parenthesis, we had 8 minus 2x squared squared dx. Okay, I can see on 1024 over 15, or I could also say I'm going to take 0.5 times 2 times my menu 43 from 0 to 2, doesn't really matter, of 8 minus 2x squared squared dx. This should give me the exact same thing, which is 1024. Okay, so that's what we're going to get down here. So we know that both of these integrals, my volume is going to equal 1024/15. Okay, remember this next test, and when you run into these volume problems on the AP test, it's mainly going to be, can you draw your cross-sectional area? Can you draw your diagram? Can you set up an integral? And it doesn't matter which integral you would set up, either one, using symmetry or not. And then we're going to plug those into our, calculator to get the actual volume out. All right? So last problem we got going on here. Last problem is we're going to take cross-sections, our squares, that are perpendicular to the y-axis. So we have squares perpendicular to the y-axis. That just means we're going to be, okay, that implies we're going to be a dy. And our functions that we're looking at here, region enclosed by all three of those right there in the first quadrant. Okay, so if I did that, I am going to look at x equals 0. That's this one. That's my x equals 0. I'm going to look at a y equals 3. Well, that's going to be here. And we are going to be looking at y equals x squared. So this is going to be a parabola here. And I'm going to put this down here. Y equals x squared. Here is our area region. So again, there's our area region. I got to shade it. And what we have is we have cross-sections that are squares, and they are perpendicular to the y-axis. Well, what does that mean? That means here is my square. Okay? And I'm going to say, here's my square. And that means that square, if I draw my square, if I'm perpendicular to the y-axis, I'm parallel to the x-axis, and my square is going to kind of look like this. And it's going to kind of project straight up on me. So I can see my area region is a square. This is my A of x. I know the area of a square is side squared. Well, I need to know how long is a side. Well, and also, this is going to be a integral. This is a dy, so my function needs to be in terms of y. Well, what is the length of the side? It's going to be right minus left in terms of y. So that means if I took this, square root of y equals x, right? So the length of that side is the square root of y, and because it's a square, it's a square root of y. So my area in terms of x, it's not in terms of x. Watch it there, Chief. My area is actually in terms of y, and that's going to be the square root of y squared. So area function in terms of y equals y. So that means what we're doing here, we're taking my integral from, I'm going to say c to d of a of y dy. So my a of y is y. That's what my volume is going to equal. Now I need my limits in terms of y. So I know I'm going to be going from here, which is 0, 0, all the way up to here, which is what? Comma 3. Well, that means this is going to be square root of 3? No, it's going to be 3. Okay, so my limits, remember, they're in terms of y, so I'm going from 0 to 3. All right, so I'm going to come back here, and I'm going to grab that, and I'm going to go from 0 to 3. And I should clean that up a little bit, and I will clean that up a little bit in just a second. And let's get that out. So my volume is going to equal my integral from 0 to 3 of y dy. That's a hard one to integrate now, isn't it? And some of them might be difficult, but that's why we're going to do them. Most of these in our calculator, but here, the volume is going to equal 1/2 y squared evaluated from 0 to 3, which is going to be, hold on, back it up here, top minus bottom. Well, the top is if I put 3 in there, 3 squared is 9, divided by 2 is 9/2. 0 divided by 2 is 0, so my volume equals 9/2, or 4.5 for the decimal freaks, okay? And that's the only difference when I'm perpendicular to the y-axis, okay? I need my function in terms of y. If I'm perpendicular to the y-axis, function needs to be in terms of y. Limits need to be my limits from y to y. That sums us up here, guys. You should have all you need to do for those few homework problems I have for this section. And tomorrow we are going to review for the test, and the next day is the test. So shortest video all year. There you go. Have a great rest of your day.